This question is titled, how do I write queries that work with hierarchical or graph data of variable or unknown depth? Because we've seen this before. If I have some sort of graph and I want to figure out what the children are, that's just a select. If I want to figure out what the grandchildren are, that's just a select with a single level join. If I want to figure out what the great-grandchildren are, that's just 2 levels of join. But I can only look a fixed window down. If I want to find any descendant of the parent, I cannot do that with the self-join, because all the self-join allows me to do is to look 1 step down the transition. If I want to look an arbitrary number of steps down the transition, that's not possible. But I can do that making use of everything that I've seen so far. What I can do is I can write a recursive CTE. I can have the CTE refer to itself and update itself as it goes. And like with any recursive formulation, it always comes down to a base case and an inductive step. In the base case, I select all the children of the parent that I care about, parent A. So if I do just this, you'll see this gives me all the children of A. Okay, great. Then I can union this by selecting all the children in my step of everything joined with the query that I just ran. And what I end up with is arbitrary depth traversal of this graph or this tree. Let me put the parent in here as well. So let's say base times base of parent here, and I'll put the base.parent here as well. And sorry, this should be step.parent, so you can see. And you can see here, I started with A, and I have A to B, I have A to C, I have B to D, I have C to D. It's actually arbitrarily traversed this because this portion of the query, by virtue of this recursive keyword, can actually refer to the result of the query itself. I call this query nodes, and I'm joining back onto the thing as I constructed. And a really cool thing that you can do in Postgres is you can tell it to annotate this with information about whether or not you had a cycle and what the exact path was. So if I add this cycle set and cycle using, I can even see starting at A, B was my child, I wasn't in a cycle, and my path was A to B. C was my child, it wasn't a cycle, and my path was A to C. D was my child, and my path to get there was B and then D, and so forth and so on. And here I can even see that this wasn't tree data. This was graph data, and there was a cycle, and I can use this to then filter, where not is cycle. So I can even eliminate cycles in this graph data. Fundamentally, the recursive CTE, even though it seems like the hardest part of all of this SQL features, it tends to be the easiest part once you think about how to decompose your queries. The name of the game, whenever you're working with SQL, is don't think in terms of the features first, think in terms of the transformations first. Are we trying to compute something on each individual row? Are we trying to filter something using just the row data itself? Are we trying to collapse multiple rows into one computation? Are we trying to aggregate? Are we trying to filter on the aggregation? Are we trying to perform an operation on a partition, but the output should look like the input in terms of the number of rows? Are we trying to expand the number of input rows so we can look at 2 rows at the same time? Are we trying to do that in order to do a one-step transition, or are we trying to look at an infinite number of rows at any one time? That's basically what the recursive CT is. Once you start to think in those terms, all of these features will melt away. And it'll no longer be a question of, is it a group by, is it a recursive CT, is it a CTE, is it a self-join? It'll be, what's my input look like? What does my output look like? Is this output a filtering of the input data set? Is it a computation on the groups of the data set? Is it a filtering on the computations of the groups of the data set? Is it a computation on multiple parallel partitions? And each one of those will correspond directly to the feature that you want. Even though it looks like SQL has a lot of overlap, the only reason why it looks like it has a lot of overlap is the way in which you think of these features is aligned like a programmer, thinking about things like in terms of variables or like pandas columnar operations. But when you see the way in which this is designed, you'll see they're actually largely independent. Of course, there's always multiple ways to do anything, but they're largely independent in their formulation. And it's possible for you to look at the problem and to work backwards from what you expect the output to be back to the input and to derive which feature you want. Now, I know we have covered a lot in this session. I know we're at our time. Nwise is not a window function. Nwise is a self-join, right? Because with Nwise, what you're doing is you're saying there's an implicit ordering to the underlying data, and that implicit ordering is based on the ordering of the tuple or the ordering of the iterable you're looking at. Python iterables are ordered. They necessarily are, because whenever you iterate over them, they have some order associated with them. Even things like the set have an ordering. It's just that you can't predict what that ordering is. It's a machine ordering. Nwise just says, look at two adjacent values. But the window function isn't about looking at two adjacent values at the same time. The self-join is about looking at two adjacent values at the same time. And so to recreate the Nwise, what you would do is you would figure out how to put ordering into your data. Because remember, the fundamental mode for SQL is the tuple space. Tuple spaces are not ordered. Even though it looks like there's an ordering to my table, that ordering may reflect the order on which the data has been inserted, the order that it appears on disk, which may have no relationship whatsoever to the ordering that I care about. Because remember, for the database, it is a multi-tenant system. There are multiple people writing to the database at the same time. Who came first is not really something that you want to base on which got written to disk first. So necessarily what you would have in that case is you'd have a column that indicates what's the wall clock time. When you do that, you say, oh, you know what? This column with the wall clock time gives me the ability to linearize to order this data. An Nwise equivalent might be, look at all the values and all the things which came before that value. That would be like an unbounded previous Nwise. A one-step Nwise would be, figure out how I can compute what one step looks like. So maybe it wouldn't be a wall clock time, because you could think that, what is one step back? Is that 1 second? Is that 1 minute? Instead, what it might be is some unique identifier like the order number, the customer number, some other ordering criteria, or something that you inserted into the data by means of your query mechanism. And you just say, oh, do the self-join and give me every result of the self-join where the left-hand side's order value, its unique ordering, is one more than the right-hand side's unique ordering, or one less, and that would give you the Nwise. The self-join is your way to look at two things at one time, not the window function, and not the group by. Hopefully, Jeff, that makes sense, and that's beginning to gel. Other questions that came up? This is so strange how SQL is set up. It is a fundamentally different paradigm that's just close enough to the paradigms that we are aware of, that we use every day, like the iteration paradigm in Python, the n-dimensional paradigm in NumPy, the columnar index aligned paradigm in Pandas, but it is different in just enough ways to make the thinking that we use to solve problems in those other tools inapplicable to this tool. And if we don't really internalize what this paradigm is in terms of transformations of tuple spaces, what's going to happen is we're just going to be fiddling with this until we decide to give up and just pull it into our Pandas data frame and do all the work there.